Okay, so today we're going to be talking about writing formulas based on the names of compounds, which we did a little bit already, which is ionic binary formulas. But now we're going to do it specifically with transition metals.
Oh, okay.
And we held off on doing these for a while because transition metals are weird. Right? Their charges can change.
You know, I did notice that you have some Roman numerals in there.
I do have some Roman numerals, which I know we don't really use a whole lot in real life, right? They're kind of old-timey, you know. So we're actually going to, you should have from your teachers a list of like Roman numerals and what they are, so there's not completely weird to you, but yeah, so you're using Roman numerals to designate the charge on the cation because it can be different.
Oh, okay.
Right? When we were talking about ionic formulas, we kind of knew what the charge was going to be, right? Mg is always +2, right? F is always -1. Those, I mean, we were easy to tell, right? But the charges on these cations are not always going to be the same.
So what you're saying is, I mean, whenever I looked at the first two groups metals, I always knew from just looking at the periodic table. But from these, you're saying I could have like a 2 or a 3 or a 4 and it'd be the same element?
Yeah. Lead could have a +2 charge sometimes, a +3 charge sometimes, a +1 charge sometimes.
So is that why we have the Roman numerals?
That's why we have the Roman numerals.
Okay,
so Roman numerals will tell you the charge.
So how do we show that?
Well, tell you the charge. So this +3 is telling me that my lead, which is Pb, has a charge of +3 on it.
Oh, okay.
Right? And then Cl, that's what chloride is. Chloride is Cl. Has a charge of what, based on where it is on the periodic table?
Well, it's in group 17, so it has 7 electrons. So that means that it is a -1 charge.
It does have a -1 charge, you're right. And I want this compound to be neutral, right? It always has to be neutral. Right now it's not. This +3 and this -1 don't really balance out.
Okay. So how would we make them neutral?
I have to add more chlorines. Since I have a charge of -1, I'm going to need 3 of them to cancel out this +3 charge on the lead. And I designate how many there are with a subscript. Right? I'm going to add a subscript. And I know which subscript to do based on this charge. I can crisscross it right here. So I'm basically taking this 3 and moving it down here and turning it into a subscript.
It's almost like the butterfly method a little bit, the crisscrossing.
Yeah, it is like the crisscrossing. This -1, I'm just going to forget about the negative sign for a little bit. I'm going to bring that down, and that's going to be the 1 on that lead.
Oh.
So in the end, I will have PbCl3.
So I noticed that you had a 1, but then whenever you wrote it out, like as your final answer, you didn't have the 1 anymore. Do we show 1s?
We don't have to show 1s all the time. 1s can be understood.
Oh, okay. So just because you wrote the lead as being there, we know we have at least 1.
Yeah, right.
Okay.
The lead existing in this space means I have to have at least 1.
Gotcha.
Right?
Okay.
And then the 3 tells me that I have 3 chlorines.
Oh.
And now overall, the charge is neutral. The compound is neutral. I have a +3 here and a -3 over here, so it's balanced out.
Oh, okay. I see.
Right. But I don't need to write these all the time. I can leave them there. Okay. And I have copper 2 oxide over here. So this 2 tells me the charge on the copper. What do you think it's going to be?
I think you're going to have to write copper. And then just like we did with lead, I think you'll put the 2 right above copper.
Yep. This copper has a charge of +2.
I see. And oxygen, I know from looking at the periodic table, it has a -2.
It does have a -2 charge. You're right. So my oxygen has a charge of -2. Oh, look, they already balanced out.
Oh.
If I were to crisscross these and bring a 2 here and then a 2 there, they would have the same subscript. So just like in math, we actually want to simplify. I don't want to keep these 2 2's here. All right, because that would look like this. And that's just kind of, it's kind of like the ones. It's actually understood that I have the same number of any, you know,
Oh,
of the two.
since it's a ratio, it doesn't matter if it's, you know, Cu4O4 or Cu6O6. We just want to simplify it all the way down.
Yeah. I want to maintain a ratio of 1 oxygen to 1 copper. So I'm actually going to keep it like this. They have the same charge and they are balanced out. Right? They have equal charges.
Makes sense.
Right? So make sure you simplify. Don't ever just, you know, leave the 2 2s or the 3 3s there.
Would we simplify? What if I had a 2-4? Would we simplify that?
Oh, yes, you would simplify that too. You'd change that to a 2 and a 1.
Oh, okay, that makes sense.
So always simplify. So I'm going to put that up there. Simplify charges. So that's something that we want to remember for sure. Right?
Definitely.
I'm going to make that into an asterisk because it's important.
Very important.
All right, you ready for the next one?
Yes.
Okay, so what do you think the charge on this copper is going to be?
Well, that looks like the Roman numeral for 2, so I'm going to say copper 2.
It is Roman numeral 2, so this would be copper 2. And then we also have a Cl, and what's the charge on chlorine?
-1.
-1. So if I crisscross these, that 1's going to come down there, and the 2 is going to go right there.
We drop the 1s because we don't
We'll
like
drop
writing
the
those
1s.
1s.
So this is going to be Cu, Cl2,
All
copper
right.
2 chloride.
So it's crisscross applesauce,
And
simplify,
then simplify.
write
And then
it
you're
out.
done. Yep.
All right.
This
that's
looks nice and clean now, right?
It's very clean, yeah. Looks good.
All right. Now we have iron, which is Fe. And the charge on the iron
Looks like a 2.
is +2. And we have an oxygen. That's for oxide. So this has a charge of -2.
Ooh, I know how to do this one. It's like the one above.
Mm-hmm.
Since they're both 2s, we can just simplify and write it out as a FeO.
That's right. So if I bring these 2 down, I got the same charge. I don't want that. So I'm going to make it FeO. I simplified.
Very nice.
These
Not FeO.
cancel each other out, right?
Mm-hmm.
Cool. Okay. Last one.
Ooh, I don't... It is lead.
Yep.
Looks like it has a charge of 3.
Mm-hmm.
And we have oxygen. The oxygen has -2.
It does.
So what are we going to do with that?
Well, this 2 is going to go down there, and the 3 is going to go down there. So this is a 2 and a 3. So it's going to become Pb2O3.
Oh, and since we can't simplify it, we just leave it that way?
Yeah, can't simplify that. So that's the way it's going to stay.
All right.
And that's why it's important to crisscross, too. I mean, you never know what subscript you're going to get, right?
That's true. It's like a box of chocolates. You never know.
Never know what you're going to get. All right. If you have any questions, please ask your teacher.
Your loving and wonderful teacher.